So, as I told, I'll be covering IAM today, and so basically, IAM is a way to manage your all your AWS resources. Um, we will get into uh, the understanding of how we can control the access between different accounts and uh, towards your different AWS resources and manage the access for your resources. So IAM, IAM stands for Identity and Access Management, and it's a web service that helps you securely control access to AWS resources. IAM is used to control who can access and at what level of permission, at what level of permission they can access the resources. So basically, it gives a control of who can sign in or who is authenticated to access the resource, and also who has the permission, who has the authorized person to access that resource, and uh, in more detail, like what are the permissions that he has within a resource to be accessed. So you can access IAM using three different ways, and those are management console. Uh, Basically, these are a browser-based interface where you go, where you log in with your credentials, and you manage the AWS resources. So basically, you would be part of an IAM as a user, and you would be logged into the system with your own set of credentials. And once you log in, you would get a browser-based interface, and you could access AWS resources. So when it comes to command line tools, so once you are part of IAM user, you would get certain set of credentials which you could use for communicating with AWS resources with the help of AWS command line tool. So there are two command line tools which you could use. AWS provides for Linux based, AWS provides AWS CLI, and there is also AWS tools for Windows PowerShell. And you can also access programmatically uh, through AWS SDK. This is also a convenient way to access your AWS resources. So there is also another way, but HTTPS and API way. So this is again access through programmatically, or you could say using HTTPS protocol. So basically, what it contains is um, it could contain digitally signed credentials. So you could see such requests in um, you know in scenarios where uh, the where the HTTPS protocol is required, or HTTPS protocol is allowed only. So you could use um, you could use this approach. So let's understand some of the IAM features. So basically, they provide shared access to your AWS account. It grants other people permission to administer and use resources in AWS account. So they also give granular permissions, where you can grant permissions to different people for different resources. So they also give secure way to access your resources. Uh, it can be like for your application that is running on Amazon EC2. instance. It also got a secure way of uh, it's a two-factor authentication or multi-factor authentication, where it can protect your account by having a second level of security. So multi-factor authentication is achieved through virtual multi-factor device or hardware device as well. So while creating this multi-factor authentication, you might have to choose whether you're going through a virtual uh, authenticator or a hardware authenticator. So once you select the virtual authenticator, you might have to set it up with your a mobile app, and or you could use that multi-factor once the connection builds, you could use the multi-factor authenticated app to log in each time. So it also provides identity federation. So what it means is it allows user who already have passwords elsewhere, for example, let's say on-premise network, a corporate network, or through IDPs, for example, Facebook or Google account. Um, so it provides a temporary access to these federated users to log into the AWS account. So it gives identity information for assurance. So you could use CloudTrail logs to track these identity information, who has used, and at what time they have used, and more information about your identity within your account. And it also provides eventual consistency. What it means is any changes that you make are made available, but not immediately. So there are certain options for you to choose what would be made available immediately and what not. So you could use this link to check that. So the whole IAM service is free of cost. So there is also AWS security token service which comes along with the IAM. So even that is offered free of cost. So before we dive into the IAM itself, let's understand what ARN stands for and how it is structured. So ARN stands for Amazon Resource Name. So any resource would have a unique name, and this unique identifier identifies the resource in AWS. So this can be used to identify not just the resource, it can be used to identify even users. And so basically you could set permissions related to these ARNs. So ARNs are very important to understand, because most of the permissions and uh, the policies are provided to this particular basically this ARN is used to um, uh, provide the permissions for the particular resource. So let's understand the format quickly. So there is it starts with ARN to denote this is a ARN, and there are partitions which says whether it's a AWS AWS resource, or what partition it belongs to. So there are several partitions that they have created. So mostly we would use, and the value that we would use is AWS. But if you are using, there are some partitions like government partitions and US government partitions and China partitions. Yeah, it would have something like AWS hyphen CM or something like that. So there are different partitions. So globally, so we would be mostly using AWS as the partition. And there comes a service part, which denotes what kind of service that we are using, whether it's a S3, or EC2 or RDS, whatever. It basically gives the namespace of that uh, product line or service. So it also mentions, from which region this resource belongs to, and it also embeds the account ID here. So there, here in this example, I have added hyphen, but the actual value will not have any hyphen. So account number would be something like this. And the last part would be, um, you know, um, would be resource ID or resource type slash resource ID. So it could be, for example, here is an example where uh, user slash, um, Bob, or instance slash the instance ID can be used. So here a user slash Bob means this is a user resource, and Bob is the identifier. So basically, this is the format which would be used. So let's understand how IAM works in a very holistic approach. What are the components which are there, and how it interacts with these components. So if you see this architecture diagram, it has principles. Principle is having users, roles, federated users, and application. So all of these belongs to principles, and these are, in a way authenticated, and request is generated, and request is sent for authorization to understand uh, what kind of policies should be attached. And next, if the condition satisfies, then um, it would move to the action or operation uh, level, where it would see whether the request is for running an instance or starting an instance, or it can be any operation. There are a huge list of operations or actions um, related to each service. For example, for EC2 service alone, there are more than 40 actions that are available. So each service would have its own set of actions. So once the action is matched, then it would find the request, and it would, the request, the resource request can be something like, it can be for an instance, it can be for a volume, it can be any kind of resource that are available. So there are various steps while how this IAM works. So from principle uh, to the request to authorization. Mind that only when authentication happens, a request is generated and sent to the authorization, and only on these validation uh, further down the line would be accessed. So you can also have resource-based policies. This is a different kind of policy, which we would understand later. But understand that with the help of resource-based policies, we can access a different account resource. So when it goes to a different account again, there would be hurdle of where that request has to be assigned a role, and again different similar kind of steps would be involved to access a particular resource there. So let's understand individually what these items actually mean. So a principal is a person or application that can make a request from action or operation on an AWS resource. So basically, this can be anything, right? So anything. It's an entity which is asking for a permission for a particular resource, and principal is basically authenticated, as I told earlier. So basically, this would be either a user or a role, and it can be when I say user and role, we can I would refer it sometimes IAM entity. IAM entity basically is combination of users and roles. So basically principal can be a root user or an entity, IAM entity. It also supports, as I mentioned in the pictorial, it also supports federated users which are not part of uh, the account at all, right? So, so basically, federated users are always programmatic access. Will have a programmatic access, and um, when they are part of the principal. So let's understand what request means. Um, so when principal tries to tries to use the console or API or CLI, um, that would send a request to AWS. So that request will include some actions, some resources. It would have more information about the principal itself, and the environment data, and about the resource data, what kind of resource that it is trying to um, talk to. So all these informations are part of each request that is sent for any communication, from the principal. So this is basically referred as request context, and this request context is used to evaluate and authorize the request. So let's understand this authentication part, which is here. So principal must be authenticated using credentials, which is sent if he is accessing through console. He would be authenticated using the username and password. But if he is programmatically accessing, then he would be authenticated using access key and secret key. And once the authentication is successful, then uh, request context is generated. So there might be certain cases where, in terms of role, where there might be more information, security related information, which might have to be passed. For example, when you're passing a token, security STS token, so then it would be part of this authentication request as well. So we understood the authentication part and the request part. So let's understand the authorization part, what it actually does, or what is the role of this authorization part. So this authorization uses the value from the request context, which is prepared from this request. So and it checks the policies um, that are that are applied to the request. So basically, based on those policies, it would decide to whether allow or deny the request. So these most policies are stored in AWS as JSON documents. So these policies are called JSON documents, which specify the actual permission of the principals. So what happens is basically there would be a document here, JSON document, and there would be a request document which is coming in. So it would match both of these documents and decide whether request has to be allowed or denied. So there are several types of policies. You could go and check that. I've added a link here. Um, um, we would go through some of those at the later point of time. And it also provides with the help of as I told, resource based policies uh, to grant permission to cross account access. So let's understand what action actually means. So after the request has been authenticated and authorized, um, then AWS approves the action, and one second, I'm sorry. So these operations are basically defined by the service. So what operation can take place on the service. So each service would have its own set of operation, as I told. So if that matches with the request context, then um, it would the request would be validated, and it would be passed on to the next level. So some of the examples are, I've just mentioned, create user or delete user. With these actions, you could create user or delete user, within IAM. So let's understand what resources mean. So after these steps, all these steps, after the approval of the operation, the request, they can be performed on related resources within the account. Resources can be any object that exists within the service. So service and resource are two different things. Service EC2 is a service, and once you spin up instance out of it, so your personal instance are resources. So uh, you would get resources out of the AWS services. And as I told earlier, these services define a certain set of actions that can be performed on each resource, and only those set of actions can be performed on these. So here's an example of what can't be done. If you request to delete an IAM role but provide an IAM group resource, do that. So the request fails. So I just wanted to mention this before we move on. So there is a difference between access key versus passwords. So it depends on how user will access AWS. So if the user is accessing through console, he would use the password, and if the user is accessing through API or CLI or SDK, he would be accessing through access keys. So these are the two credentials that would be providing at a with a different set of interfaces. So here's a best practice that has to be followed. In either case, make sure that you rotate the credentials regularly. What rotate credential means? Um, so if you have the password, set a policy to change the password frequently, so that you can for after a month the same password should not be used. So that's what rotate credentials mean. And if you are having access keys, um, it's a good idea to have that policy around you to expire old access keys and generate a new access key and use them. So there is something called as a credential report to audit uh, credential rotation. You could use that report and find which uh, credentials has to be rotated. You can configure password policies, as I told earlier. You could also configure policy to allow uh, access key rotations. So these policies has to be explicitly granted um, at a user level for them to generate these access keys and passwords, and also to expire these passwords and access keys. So AWS provides us a, a structure where we could manage all our accounts uh, under one roof. So that is provided by uh, a service called AWS Organization. It's a feature where um, you could manage all your accounts under one master account. So you could have a lot of projects, and you want to have one billing account. Then you could create an organization and bring all your other accounts under that master account, and each account under that is called organizational unit. So this is just an example which says unicorns and zombies. And unicorn is a project which has um, different environments, production and development environment, but they would be part of single organization unit. This pink box denotes two different accounts under one organization unit. So there can be many uh, accounts under one organization unit. I'm sorry, one second. So let's understand the AWS account root user, what you root user means, and IAM user means. When you first create an AWS account, then a root user would be created. So you begin with a single sign-in identity that has complete access to all AWS services and resources in the account. So this account has a lot of privileges, and I mean it is not lot, it is all privileges. You cannot reduce the permission associated with your AWS account. So basically it is assigned, it is accessed by email address and password. So it is highly advisable that you don't create any access key to this account. You And it is also advisable that you create a multi-factor authentication to your account. So basically this would be your billing account. So any billing associated account would be your root account. So from this root account, since it has several restrictions as part of AWS recommendation, so it is advisable not to have any technical uh, actions to be taken using this account. So we create something called as IAM users. So we create a user with full admin privileges, and using this account you could actually create more users and do all the regular daily activities uh, with the IAM user. So the root user will have three major tasks, I can say that. So those are something like you can create IAM users, you can give authorization to these IAM users, you can manage billing. Root account should basically use to manage the billing, though your root user can give permission to IAM users to manage the billing, but mostly it is the convention that root user should be used to manage your billing. And you could using root account you could track users activity using cloud trial. So your root account is used for mainly only three different purposes. So one is creating user, managing user, you could say, and managing billing, and track user activities. So other than that, uh, root user should not be used for any technical functionalities, or technical uh, or business related functionalities, purely for operational purposes. So IAM users, so root user creates IAM users. So this would be a part of our account itself, but no, this would be a separate entity, IAM entity. And this IAM user would have a separate user ID and password to access into management console, and also programmatically access through access key credentials. So they do not basically it is advised that you do not share user credential with other employees. So if you want other employees to access AWS, create their own account and provide them with access credentials. Um, so there can also be instance where application itself has to access. So even in those cases, you have to create a user for those applications to access access the AWS resources. So in any case, you would be creating IAM users uh, for any different kind of IAM entity who is accessing the AWS resources. There is also uh, you know third kind of user that we talked about earlier, right? So they are not part of AWS account at all, but they still need access for AWS resources. So a root user and IAM users are part of AWS account, but federated users are managed outside of AWS, but um, we would provide access, they would gain access to AWS resources. So let's understand what are those scenarios or who would get those access. So those users can have identities in corporate directory. So basically it means that in the corporate in a separate entity or a separate on-premise network, you already have a directory or user account created, and you want to provide access to those all the users under your company to uh, to provide access to AWS resources. So what you could do is you could achieve that using SAML 2.0 compliant corporate directory. If your um, company is not SAML 2 compliant, what you can do is you can have a custom identity broker application to achieve this same similar kind of functionality. You can also establish trust between AWS Directory Service and Microsoft Active Directory. So there is already a service built by AWS called Directory Service to communicate with Microsoft Active Directory. If your corporate is using Microsoft Active Directory, there is also another way where user can access these AWS resources, that is through internet identities. So you could use these IDPs uh, to provide access to our resources. So these are basically achieved through one of the ways is Amazon Cognito service, where it would communicate with your IDP and give you a token, and you could use this token to communicate with AWS resources. So these federated users always get a temporary security credentials, and they are associated with a specific IAM roles. So basically, IAM roles defines the permissions of the AWS resources. So these federated users always as in when they try to log in into our AWS system, they would get a temporary credential which will have an expiration time. So every time they try to make any communication, and after a certain period of time that would expire, and they would ask for a different set of credentials. To use identity federation with internet identity providers, it is always recommended to go through Amazon Cognito. But without Amazon Cognito, also you could achieve the same kind of functionality. So let's understand and let's summarize what IAM user and federated users are. It actually depends on the user, where the user are put in. So if it is an on-premise, you would say a federated user. If it is an AWS account, then they are IAM users. So federated users are basically accessing our systems or accessing AWS resources through IAM roles. So they can only access through IAM roles. So you might have to remember this part. So this is the most important part. So temporary credentials, whenever we say temporary credentials, it is mostly through IAM roles. So other important use case is delegating access to your accounts. So if you have a different organization with and if you have an organization and you have many accounts under that, and if you want to access if you require cross account access, then you could use these federated users as well. And mostly the mobile applications access these resources through federated access. So briefly, let's understand how federated access works. Okay. So here there is an IAM user. He is from a different account. So he will ask, sorry, he will ask uh, for access to this prod.example.com account. So this guy would give him a role saying that you have a temporary credential which will provide you a DB role. So you can only make access or only have API call access for a DB. So once he gets the role, he would pass the temporary credentials along with the API call. Then that request is authenticated and uh, the response is sent back. So if you see here, the role is basically assumed through STS. So the account, the Anders should have STS assume role in him. Only then he could assume role from the prod example.com. So the role that this provides would be something like this. So it would say basically trust this IAM user, and the principal actually mentions this user's account ID, and he could assume this role, and it would also include the permissions related to what kind of actions that he could do related to DynamoDB. So this is how the federated access works. So basically, this is how you enable credential rotation for IAM users. So you take the first step would be first you create a set of credentials when the older credentials is still active, and update all the applications to use with the new credentials. Then change the state of the first set of credentials to inactive and test again. So using only the new set of credentials, confirm that all applications are working well. Only after that, delete the first set of credentials. And also note that if you are when you are rotating the credentials and you have a old set of credentials, you have turned it inactive, then you have made a new set of credentials active, it is always advisable that a credential which is made inactive and which is already tested, when the functionalities are tested, the old credential has to be deleted. It's a best practice that you should be following. So here is a sample policy for that you should have to achieve the uh, access key rotation. So basically, this what this policy means is you have IAM policy to create, delete, list, and update access keys, and this variable basically is populated with your um, current account. So whenever this is attached as part of your principal, this would be populated with your username, such that you could do uh, the access key rotation. So we understood what users are. So there is another aggregation level where user can be grouped to do a certain similar set of actions, or particularly what they are responsible for. So they all fall under groups. So groups is basically a structure what AWS provides us to um, collectively assign certain permissions or policies um, to the users. So here is an example where there are admin group, developer group, and test group. You put all the users whom you want under these groups, and they can be part of two groups as well. One user can be part of two groups. Here, if you can see, Brad is part of both admin and developer group. So user can be part of two different groups and have two different set of permissions to uh, access the resources. So each group will have multiple users. They said each user has more than one uh, group. Each user can have more than one group. But the thing is, you cannot put group inside another group. So you use basically policies to grant permissions to the groups. So let's understand what IAM role means. So IAM entities used to delegate access to users or application and AWS services. Okay, so basically, IAM entities are users and roles. This is intended to be assumed by trusted entities. So whoever is assuming that role would mostly be a trusted entity. So once these roles are assumed, the permission which is attached to these roles are delegated to the entities, and IAM role do not have credentials. That is the you know most important thing that we need to understand. So these roles are temporary, and they are assigned to trusted entities uh, on a need basis. So they are generated dynamically, so they are associated with the trusted entities dynamically. As I told, these are temporary credentials, and these roles can have a many to one relationship. So therefore you can enable many users or application to assume the same role and grant same set of permissions. So these roles are assumed through Amazon security token service. So this actually sets the permission which says whether what kind of role can be associated with the entity, or can he assume that particular role. So we will see what kind of a role uh, which can be assigned to that entity. Mostly roles have many different use cases, so they are broadly categorized into three. So the first use case would be granting access to AWS services, and the second use case would be federated identities, which can be granted access as roles, and you would assume role uh, whenever you want to enable cross account access. Let's understand what that grant access to AWS services mean. So there are a lot of AWS services in their portfolio. So uh, you could grant these services accesses on your behalf. So one best practice and also one thing we already had seen a demo is attaching roles to EC2 services, EC2 instances. You could go to EC2 dashboard, select an instance, and you could attach uh, a different kind of role. In our previous example, we tried attaching S3 read-only access, where we could, query the list the bucket names of all the S3 services. So the best practice is always um, attach a role to the EC2 instances rather than you going and manually attaching um, roles to your application within the EC2 instances. So if you have a particular application within your EC2 instances, a single application, and it has got a specific uh, policy or that needs a certain set of permissions, then you could attach that role to the whole EC2 instance itself. There is also a service role which you could attach on your behalf. So this gives the control permission to run certain set of applications, or uh, basically to control certain set of AWS resources or services. So some of the examples are like AWS config, opworks, and directory service. These, if you want to take an example of opworks, you could actually give a role to opworks where it would generate different instances, different resources on behalf of you. So opworks is one of the infrastructure as a code functionality or a service provided by AWS. There is also a new variant of granting access to AWS services that is called service linked roles. So these are already they will have a predefined set of permissions that are linked to the service. When you enable those services, um, it would do certain set of actions on your behalf. So one such example is Amazon Lex. When it comes to IAM, there is also something called as Access Analyzer. It also has certain set of service linked roles, which could analyze whether your IAM user has certain set of access, and it would give you a consolidated report, or uh, you could find out who or what users have what kind of access. So access analyzers are linked are provided with service linked roles. There are, as I told, there are federated identities. So these so if you have an organization and it has its own set of identities, you create IAM identity provider entity and establish a trust between AWS account and your IDP. So you use roles to grant permissions to this. So we already went through. There is something called a SAML IDP, which there are two uh, different variants. One is SAML 2.0, or you might have to, if your company's corporate identity providers is not SAM 2.0 compliant, you might have to do a custom identity broker by yourself and use the single sign on capability. So you could also do the OpenID Connect provider, which is basically a lot of companies are using these OpenID Connect compatible IDPs. You could also enable cross account access. That is, you could assume a role from the command line. Could configure that and access different account, or you could switch role in the console itself to access certain accounts. So this happens when you have organization enabled and there are a lot of accounts within your account, um, within your organization, and you could go and switch the account on the your my profile section, which is on the top right corner. You could go and just switch the accounts within the console. So there are two ways that you could do it. So just a recap. So we have got roles. This would have certain set of permissions, and these permissions are temporarily given to either users or EC2 instances, or it can be given to any AWS services um, as well, and also some federated users or any federation entity. So role has two parts. So that is, who can assume the role and what permission does that role have. So you should always remember that there are uh, a role who will assume it and a permission that is along with that role. So you might be wondering, you know, when it comes to security, that uh, earlier we discussed about many to one relationship. If you are attaching many, single role to many users, how would you track who would do what, right? So let's say there are five users here, They are assuming a role, and after assuming a role, they are doing three different actions. So they are putting three different objects in a bucket. So if you want to track, let's say, for purpose for your own, tracking purpose, how would you do it? So there are steps to achieve it, and let's quickly understand how it is done. So step one is, first you have to locate your you know put object call, uh, where this call was made, using the object name. So here in this example, we are using S3 bucket and the object here. So the second step is find the uh, you know assume role call using the temporary access key, which we got from the previous step. So the third step would be finding the uh, assume role call from originating account, because this might be from a different cross account, uh, using something called as shared event ID. So I've got a code snippet which will even give more clarity on how it is done. So first step is the access ID and what is the event that has happened. So put object has happened, and this is the key of that object, and we would capture this account access key ID for our next step. So next is we would find in the cloud trial, for this access ID, what is the shared event ID. So every access ID would have a shared event ID. So you would capture this shared event ID and go to that respective account and find the actual user. So this has to be done in that respective account to find out who is the user. So if you have two accounts, when communicating between the two accounts, shared event ID is used to communicate. The actual identity of the person is not shared. So something to remember. So let's understand what the security token service means, or what are the functionalities that security token service provides. AWS STS is a basically a web service that enables you to request temporary limited privilege credentials for IAM users. Okay, so it can be federated users as well. So these temporary credentials work almost identically to the long-term access keys credentials, but there are subtle differences. So there are two main differences. So they can be configured to last from anywhere from a few minutes to several hours, and these temporary security credentials are not stored in the not stored with the user, but they are dynamically generated. So when the temporary credentials expire, the user can no longer make the same similar kind of request till the credentials are renewed. So some of the common scenarios for temporary credentials are, if you have an identity federation, which we already talked about, it can be enterprise identity federation or web identity federation. So enterprise is using corporate directory. Web identity is through IDPs. So you could also have a role-based uh, cross account access. So you could use STS is used to generate rules for the cross account access, and you have uh, rules for EC2 services, which we discussed earlier. We said that we tried EC2 instances. We added rules to EC2 instances where it could access uh, S3 buckets to get the to list the objects or list the buckets itself. So what happens is it would communicate with STS and get the temporary credentials and then make the request to these S3 buckets to get the resource information. So as and when you attach this role to EC2, it internally manages the this key rotation, the credential rotation. So as I told earlier, security. This is a temporary credential which is assigned. So as and when you assign it to EC2 instances, EC2 instances will manage to rotate the credentials and have a valid credentials always to communicate with the resources. So there are also other AWS services that work with IAM, so you could check more on that. So some of the following actions that are supported here. So whenever you are making whenever a user is assuming a role, then STS would provide assume role as the permission. If he is a federation user, or if he is doing through enterprise identity federation, then he would be attached with assume role SAML with SAML, or if he is with web identity federation or IDPs, then the assume role with web identity would be attached as part of the permissions. So AWS also provides a service called Amazon Cognito. So Cognito was mainly built to provide authentication and authorization, and it was uh, you know uh, to provide user management for mobile application mainly. Then it was also extended to web applications. So user can sign in directly using username and password through this uh, through Cognito, and basically it also provides the integration with third party. So it could be Facebook, Amazon, Google, or Apple. So Amazon Cognito has got two main components, that is user pools and identity pools. So user pools are basically a user directory. So whenever a user signs up, um, or a sign in option, sign in, so these information are captured in the user pool. So all your sign up and sign in options are captured in user pools. Identity pools basically enable you to grant access to the AWS resources. So it is basically an authorization uh, model which tells for this particular token, um, for this particular user, what is the access for the AWS services. So basically, this is the step that would take. First, the app would request for a token by sending username and password. Once the app has the password, it could use this password to communicate with the identity pool to get the required credentials. And once you have these credentials, it could communicate with the different AWS services as and when it is required. So let's understand IAM policies. These are something which are very basic in nature when it comes to IAM. So policies provide authorization to AWS services and resources, right? So basically, these are the entities or uh, the uh, factor which would say what is the permission that the particular user has or principal has to access the particular resource or a service. So the two parts of these policies are specification and enforcement. So specification means it basically defines the access of the policies, and enforcement is basically evaluating the policy. So there are two things: one is defining the policy, and another part is evaluating that policy. When you define these access policy, uh, you specify certain set of parameters. So these parameters are something like IAM principles, and what these IAM principles are allowed to perform, uh, and which action is allowed to perform on what specific AWS resources and under which particular condition. So it defines the access policy. So this policy is enforced by evaluating the AWS request and the policy, and it basically gives you the answer of whether this is a valid policy or invalid policy. So this is the policy structure. So policy structure is this: it will have a statement, it has an effect basically say whether what has to be allowed and what has to be denied. Principal basically has the entity details. So he is an example that example of an entity. Basically, it says some user with a username is the principal here, and it also mentions what action he is allowed or denied. So basically, effect would say whether it's an allow or denied, allow or deny. So the action would be S3 or S3 get object. It's just an example. The user with the username has S3 get object permission here, and the resource would basically mention what is the resource that he is trying to access. So in this case, for the account ID, Q1 is the resource, Q1 is the object name, and you can also specify a particular condition for this for this policy. So the condition is, in this case, it says the request tag for the policy, it can be applicable. So we will understand what request tag is you know um, next few slides, but just understand that there are conditions which you could have which says what has to uh, address whether If the project contains a uh, pickles as the string, only then do this particular action. So that was the policy structure. So basically here, what we are trying to get here is just to understand, to summarize, it's basically a JSON format, which we saw earlier. Effect can be allow or deny. Principle is who is allowed access an entity. Action is what actions are allowed or denied on that resource. Resource is which AWS resource does this permission apply to, and the condition, if there are any additional conditions for fine-grained control, we could use this condition. Here are some of the examples you could refer. So there are a lot of examples here. I would check one or two. So let's say if you want a specific accounts, you could say AWS is equal to 1234 this account. So this would mention a specific. This would mention the whole of the account, and this also mentions a specific root account. Or if you want an individual user, you could say user slash username here. Or if you have a federated users, so there are a lot of principles here, in the policy principal policies could attach. So it could be, here you can see it can be anything under AWS. It can be root account, or it can be generic in nature. It can be a specific individual user account, federation user, or a specific role that you are assigning. Role can also be a principal. Or it can be a specific service which is trying to access. So EC2 is trying to access S3, so you could specify that as well. So here's an example for actions. So start instance, change password, and you could do either, you could pass multiple values as part of the actions. You could have a wildcard here. It would say here, if you say put star at the beginning, it could be create access key, it could be delete access key, it can be anything. So you could use star and control the policies. It's a powerful tool when you are using it. I'm sorry. Let me mention that there is also something called as not action element. You should check that out as well. Whenever you want to deny a certain entity, you could use that not action as well. So similar to that, we have resource and not resource elements you could use, and these resource could be any resource that we have under, and you could use wildcard under it. And um, there are many patterns that you could use to access the resource or resources. So here's an example of condition. So what we need to understand is there are AND operations and OR operation which will be performed. So in this example, what we have is, if you want to restrict access on a time frame and for specific IP address ranges, then you could use this condition. Here it means that all of these should be satisfied and one of these could be satisfied. So whenever you put a flower bracket, I'm sorry, big bracket, so it would, anything under this would be, you know would be operated under OR operation, and anything which you add under the condition will be operated as AND operation. And if you add more condition tag itself, that would be uh, uh, executed as and as well. So you could have multiple conditions itself, so that would be applied as applied with the and operator. If you have, let's say, if you have comma here and more conditions here, another set of condition, both has to be met. So let's quickly understand the policy evaluation logic. So the first decision starts with the deny. So it will evaluate your uh, applicable policies. If there is any explicit deny of that policy, which is matched, so it would be denied. If there is an explicit allow of that policy, then it would be allowed, or else the default would be deny anyways. So you won't have permission to access any resources without explicitly adding allow to it. So default is deny. There is also something called as explicit deny, and only way to access your resources would be explicit allow. So just to recap, we have policies. Policies has permissions in it, and these policies can be attached to group, role, users, and resources, any resources. And group has group users who are under this group will inherit the same kind of permission that is attached to this policy. So policy has uh, two different kinds. One is inline policy, other is managed policy. So inline are embedded to the particular entity or users, uh, uh, you know, IAM entity, could say. So managed policies are reusable in nature and they are managed by AWS. There are also some managed policies which are created by customers, and each would have different versions, and you could manage it um by deleting those versions and updating um, the default version and things like that. So these inline policies are not shared between many entities, so these are just applied directly to those entities. So inline policies enforce strict one-to-one relationship between policies and principles. So they avoid wrong policy being attached to the principle. So this gives you a specific permission to the principal. So even if you have broadly given permission to those principles, you could deny with um, with the inline policies. So whenever you have to ensure that whenever we delete the principles, we delete the policies as well, because they are not implicitly deleted. So you could use manage policies when you want to reuse it, and with the help with this manage policy, you could centrally manage it. You have version, and you could roll back those versions, and you could delegate. Delegation of permission management is very simple, and you have automatic updates in case of AWS managed policies. So these are, we will see how or what are these updates and how these managed policies get updated. So there is these managed policy have got larger policy size, and you could attach uh, more permissions within these policies. So we also spoke about briefly earlier about resource-based policies. So resource-based policy is a policy which is which is attached directly to the resource. So in our previous session, we saw a bucket policy which was used to restrict users or uh, uh, any principles. So you could use those resource policy um, for those for the services, AWS services directly. So IAM policies are basically IAM users are applied to IAM users, IAM groups, and IAM roles. So some there are very few resources which allows to have these resource-based policies. So one such example which we saw earlier was bucket policy. So basically, these bucket policies are will not contain a managed policy. You cannot apply a managed policy. You have to explicitly mention um, those policies. And one of the very important, attribute or parameter of that policy would be principal. You have to mention who is the principal for that um, within that policy. This is just a recap of how policy works. You have unique context of your request. You have user defined uh, policies. Both are matched together, and once the request and uh, request context and policies are matched, then the allow or deny action is taken. So let's understand some of the policy types that we mentioned earlier, and some of its core use cases. So I mentioned something about AWS organizations. If you have created AWS organization, then you could control or you could manage those accounts using something called as service control policies. So these provide guardrails to um, disable some of the service access based on the principles in the account. So these are very important and also widely used um, policies when you have organization and many accounts under those organizations. So we generally use, if we don't have organization, let's say we don't have organization, or even if you have organization, we have something called as IAM. This provides a granular permission to your IAM principles. So they have two things under them. One is permission policies, which are IAM regular policies with permissions. Another uh, component is permission boundaries. So let's understand permission boundaries in a bit, but understand that there are two kinds of permissions that are provided by IAM. One is permission policies and permission boundaries. So there is also a security token service. where they provide scope down policies, which says uh, what action or what permission has to be uh, performed at the request level. So there is also specific AWS services which provide resource-based policy, which we saw, something like S3, which provides bucket policies. There are also VPC endpoint policies, which provides access uh, or permissions to access certain services. So one of the example is uh, VPC endpoint, which could connect to S3 bucket, and uh, S3 bucket would be made, um, you know, would block public access, and we would provide the permissions to VPC endpoint uh, to communicate with that S3 bucket. So all of these policies use the same policy language, that is JSON document policy document, which is in JSON format. So the structure and the components would be the same. So let's understand the permission boundary. This was recently added as part of IAM. So they basically will help developers to provide permissions to their applications or any entities that they create. So what as an administrator would do is he would define the set of permissions, what the the developer can do, and developer can use or build certain set of permissions for any IAM principle only under those the boundary which is within the boundary. So what it means is, uh, as an administrator, I would say you could create applications. You could grant access to those applications um, to communicate with S3 or SQS alone. So when such boundaries are made, developer cannot grant access to the application apart from these two components, these two services. He cannot communicate. He cannot make application uh, communicate with other EC2 instances or any other services. So these are permission boundaries specified by administrator, which as an employee or as a developer, I could safely use and grant the permission to the principals. So this is the flow how it works. So admin creates the maximum permission that a developer can have. This would not be for the developer, but basically it would be for uh, the application what developer would be creating. So admin allows developers to create roles with maximum permissions. Then developer create roles with maximum permission and specific permissions. So developer passes the role to the application resources. So what it means is, admin provides developer certain permissions where he could create roles for only to a specific applications or resources. So there is certain things like how policy work within an account and outside the account. So there are service control policies. These are provided by AWS organizations, and whenever a request comes in, it checks for the service control policy. Then it would come for IAM, it would check for IAM policies. If IAM policies are present, then it would check under that, and then next it move on to permission policy. Permission policy has either managed policy or IAM inline policy. That would be compared again, and if there are any scope down policies, that would be matched as well. So scope down policy could be provided by STS. And if it is accessing any resource based policies, then uh, it would check for the policies under the resource based policies as well. So here it would be something like, uh, if there has to be two things which has to be approved. One is service control policies, and uh, either IAM policy or resource based policy. But when it comes to cross account, um, if you are trying to access resource based policy, then you should then you should have IAM policies attached and resource based policies attached to it. Otherwise, you couldn't have the cross account access. And just to mention this, if let's say if permission boundaries are present, and your certain permission are not assigned, it means that all other services which is not mentioned are implicitly denied. So if there are no permission boundaries at all, then everything is allowed. If there is a permission boundary and no explicit mention of allowing of service, then everything will be denied. So let's understand some of the best practices for using IAM roles. So there are mainly you know two components, right? One is trust and another one is permission. So we validate trust policies to ensure only appropriate entities can assume that role, and set granular permission on IAM roles, and use scope down policies for further access control. And we can track cross account access using AWS CrowdTrail. So let's see how we can trust the policies for AWS resources. So first thing that when we are trusting a policy for AWS resource, what we need to check is the principal, and we see whether uh, the service and what services it is allowing. So basically here, if you see that we are having STS assume role. So for trusting a policy for an identity provider, the principal would be federated, and the it would add the ARN of that. And if you see, notice here, the for the federated principal, we have action of assume role with SAML, and it could be identity as well if it is an identity provider. So this is an example of a trust policy for another account. So here is a, a user ARN attached, and we are saying we are giving this a user to assume the role. So in this case, the principal would have the user slash the username mentioned here. So whenever you're validating any trust policies, the most important part would be the principal, because this would determine for whom you are giving access to. If you For an example, if you pass role here, then every user under that, I'm sorry, if you mention root here, then every user under that root for this account would have access. So there is also something called as tag based access control, so which is very important. uh, from past recent years, it has become a very important part of IAM. So what you could do is you could attach these tags to these resources, and you could control the access of your IAM users based on these tags. So permission assigned to, in this case, Anders, is he could perform easy to action on resources tagged with project and blue only. So he can't create, or he could not perform any action related to EC2 when it comes to tag which is having project.green. Project is equal to green. So project and green key value pair. So this is kind of a tag based tag level of access control that you could provide it to user. So let's understand these tag based control. There are basically three parts required for tag based control. But before we understand the part, let's understand what request tag and resource tags are. So request tags are new tags that are going to be requested, and resource tags are, these are the old tags that are already assigned to the resources. So that is all the difference between request tag and resource tag. Resource tag is basically the old tag which is already assigned to the resource, and request tag is you're requesting for a new tag to be allocated. So basically you allow users to create when creating a resources. So you basically allow users to create tags when creating resources, but require specific tags when user create resources, right? So you would request the you would have the request condition to require specific tag specific tag value during creation action. So you have to mention uh, with a request tag what specific tag value you need to have during the create action. The second part is you control which existing resource and value developers can tag, whether it's a resource a request tag or a uh, resource tag, or it can be combination of both. You can control resource you can control resource user um, basically can manage based on tag values. So with already having let's say user uh, sorry let's say there are resources which are already having tags, and they can be controlled using a resource tag. Let's see quick example of how it can be done. So here uh, in this policy example, we have specific tags when user can create new resource. Okay, so here is an example. So the action is easy to run instance, and he can run an instance for any resource, okay, under uh, the project, under the keys project and name under tag keys. So in this case, the request tag has to be project and the value to be darky, and the region has to be US West 1 and or US West 2. There's an or condition here. So what this basically means is the this tag allows projects or name but nothing else. So your resource, whenever you're running an instance, your the tag for those instance should be project or name. Since it also has a request tag for those project and the project name is darky, this running an instance is a new instance. It has to be a new instance because the request the tag is request tag. So this basically requires a project tag and must be the darky value. The second example here is you could create tag basically to control which existing resource and value developer can tag. So here, this policy mentions whether the developer can tag an existing resource or not, and with what value. So what it in this example it shows that only tag resources with darky can be can be used to create tags. So and the tag value can be either project or name. So what it means is, if since he already has a resource, he could add a name tag to it. And there is also another condition in this, and it says if you are creating a new resource, then the project name has to be darky. So this is how you basically mention the policies to create tags and control the users from creating or different resources using tags. So let's understand some of the best practices that are followed this section, followed with the IAM. The first is always lock away your AWS resource root user. Always use your IAM user whenever you're accessing any technical functionalities. So you can create individual users and use them. Use groups to assign specific permission to IAM users. So you could group these users based on different permissions and you could use them. So the uh, the recommendation from AWS is always grant least privileges to the resources. So use custom managed policies instead of inline policies, another best practice, because these customer managed policies can be managed with different versions, and uh, you could manage those policies as and when required, and use and these managed policies are always reusable between many between many principles, or I'm sorry, between many entities, IAM entities. Use access level to review IAM permissions. Configure strong policy, password policy, which you could do it. Enable MFA, multi-factor authentication. You could use roles for application that run on EC2 instances, which we just discussed. You have user roles to delegate. You have roles to delegate permissions. So you could use basically in the background, it would be STS would be used to get these roles. Do not share access keys, and always create a new individual user. Rotate credentials regularly. Remove unnecessary credentials. So whichever is the credential whichever are made inactive has to be removed. Use policy conditions for extra security. So condition would give more finer grained control of the security. And the last one is monitor activity in your AWS account using CloudTrail. So these are some of the best practices which you should be following. So let's quickly go through a demo of these services, or understand the layout of these services. So I'm going to IAM service. So you could go through here, just say IAM and select the IAM service. So as and when I land, I get to see the dashboard. Here I have deleted the root access keys. You could go and see that as well. See, I will just show you an example of that. You could see there is root account access, and I have sorry, here I have deleted these access keys. You could create a new access key. You could download that. You could always show the access key here, and you could make it inactive. And the best part is you could always turn it back whenever required. You could make inactive and delete it off if you don't require it anymore. So this is the dashboard. So dashboard gives me some of the insights about how many users are created. So there are 2 users which I have created with different access key age. So it was created 46 days back, things like that. There are groups which I've created. I have admin 1 and admin 2, and admin 1 has 2 users under them. So he would get all the permissions under this user, under this group. There are 27 roles which are currently available. So there are policies, and there are custom managed policies here. Let's understand these policies now. So there are, as I told, there are customer managed policies and AWS managed policies. There is also another kind of policy called AWS managed job function. So what it basically means is if we have a specific set of job, then you could attach these policies to that um, users or entities. Basically this define a specific set of job. So for example, it would grant permission related to billing, it would grant AWS analytics service, which is already, these are the services, these are the policies which are already built by uh, AWS, which are managed by AWS for a specific job. So these access policy, administrator access policies would be, you should assume this, you should add this policy to your first IAM user, which you would be using alternative to your root account. So there are plenty of AWS managed policies. There are around 600 odd AWS managed policy, which would have depending on the depending on your need. So some lot of them are already built. So if you want full access to EC2, you could just use this, or if you just want read only access, you could just use this policy, and you could actually go into these policies and check what this policy actually means, and what are the permission that they're providing. So you could basically attach any user if you want directly from here. So these are the versions which I was talking about earlier, which you could see. So basically there are a lot of versions which they have changed. So from 2018 uh, February to November, there was a version bump. You don't have permission to change these versions, so because they are managed by AWS. So this is access advisor, which I was talking to you about. So this provides full access to, basically this says what is the, who are the users are having that permission and all that. So uh, it gives you some insights. So let's go back to policies and just check our custom managed policy, customer managed. So there are nothing, it says EC2. So I have some DB2 get item policy. This is the policy that I have. I can you know see the policy usage. So it is used by a role which I have assigned, and I could change the policy, and let's see what are the changes which are there. So this has got Visual Editor 1 and Visual Editor 2. This has got Visual Editor 0 and 1. So you could actually go and edit the policy in a JSON format editor. This is just an example that I'm trying to show. So I'm just saving these changes under this, and you have a new version here. If you don't want to use this version, you could say set as default, and version 2 becomes the default version. You could always go and delete the version that you don't need. So let's see, let's quickly go back to roles. So you could always create role here and attach that roles to any service or entities. So as and when you say I want to create role, you could create role for the service, you could role for another AWS account, a third party, you could create role for web identities or SAML federation. So let's go and create a role for EC2. So I would say I could use this policy. I could set boundaries uh, basically, uh, and I would just say yeah, I can create policy here, and you could use a visual editor to what kind of policy it would generate a policy. I would say EC2, and I would say I want list all. Sorry, list all EC2 instances. If there are any resources that you want to attach, since I'm using list, you can't do that. And sorry, you could specify a specific ARN or things like that. Let me go and check this read. You could specify kind of source IP, any conditions. I'm not going to do that now. Language policy, I could name EC2 list, and I could just say create policy, and your policy is ready. So that would be your managed policy, EC2. Created a role here. Sorry. So we are trying to create a policy there. Now we could use EC2 policy. So here is a new policy that we created right now. So let's, you could tag it, say project next review. I could add name EC2 list role. So a new role is created. See that here. So we created role by attaching a policy as well. So there are, this is user, we saw that earlier. You could create new group. It can be developer group, and I wouldn't give the developer access. I would say developer. So there are some cognito developer policy. I would say EC2 full access. So why not? Let's give EC2 list policy here. So I'm attaching a role to a group. So a new group is created. Now I can go and add a user to this group. So admin user 1 is also part of two groups. One is admin group, another is developer group. So IDPs, identity providers are, as we discussed, we could create two kinds of identity providers. One is SAML and OpenID Connect. So if you have a particular SAML connector, you could use that here, provider. You need to generate a metadata document and attach it here. And OpenID Connect is basically something like if you have a Facebook account and their client ID, you can mention that and you could create that. So basically this helps you create a provider and helps you communicate between the federated users and um our AWS account. There are some account settings that you could do. You could change password policies. You could change you know some of the STS related actions. So you could deactivate some of the locations, regional endpoints locations. So this is a new feature that has been now added recently, and this creates analyzes though, so you could find out um, which user is using what kind of permissions and what are the rules and um, what is prohibited, and you could track that using this access analyzer. You could generate reports out of it as well. So credential report would give you some kind of report which would show what is the access patterns and related to the user account. Let's see in a moment what is that. So it gives there is a root account. There are three different users. Um, what is enabled here, what is not enabled here, whether he has the access key for a particular location and things like that. So this gives you a complete report of uh, access key related to that user. So this gives you a organization activity. If you have already created organization structure, there is one user under developer. So you could add more account under this if you have multiple accounts. Since I have only one account, I have created a folder called developer and I have attached to it. So you could create more folders under this root, and you could attach more accounts into this under this folder, and you could use service control policies to control the um, account level permissions under these accounts. So basically you could go and create accounts under or attach under AWS organizations. So this is where you add accounts. So basically when you say add account, you could say invite account. I could give the account ID and invite, and it invite request would be sent to that new account, and they can be part of this organization as well. Or if you want to create a new account, then you have to give the d- you know full name and different email than your root account, and create an account for it. So that is all I had in mind to show you place. So we could just a moment, I'll just show you the EC2 attaching roles to EC2 again, just in case you have forgotten. So it's very simple. You could go create an instance, launch an instance very quickly, and I would show you. So I launched an instance now. As and when you launch an instance, you could do certain actions, right? So if you come to uh, instance um, settings, and you could say attach and or replace IAM roles. If you come here, you could always attach any roles that you want to use. So we created EC2 list role. I could just attach that role and apply it. So now this any application under this EC2 instance can list the EC2 instances available.